Hi, we are the team, and we're going to present two different circuits solved with two different methods. My name is Santiago Rodriguez.
My name is Leonardo Lopez.
My name is Carlos Mendoza.
To begin, we're going to present a circuit solved using the mesh and super mesh method analysis to obtain I, Y, and Vx. Carlos Mendoza will present the circuit.
Okay, so now I start sharing the screen. Uh, how you can see, this one is gonna be the circuit that I'm gonna solve on the circuit simulator. So first of all, I'm gonna start using the independent voltage source. So this one, I'm gonna put it right here. And also, I'm gonna use independent current source. Uh, and I'm gonna put it right here. So I'm gonna start with the first wire going to here. And yes, here I'm gonna need my first resistance here, and I'm gonna put it with a value of 14. Then I continue with another wire, and I stop here to have my another node, and I'm gonna go downwards, and I'm gonna go this way also. And here I'm gonna have my second resistance that's gonna have a value of 15. Yeah. So we continue with the wire. Here, and we go downwards. Here, we're gonna use these two nodes to connect other two wires. This one will go like this. This one will go like this. Okay, so now I'm gonna need a voltage source. Here, the voltage source is right here. Yes, and we continue with the wire. Now I'm gonna need also a current source. And we get it from here, input and sources, and we get at current source. Nobody has to go upwards. And this one needs to have a value of 2 amperes. Okay, now I'm gonna continue with the wire. And continue through here. This one is gonna be another node that we go upwards. And this way also. To connect to the B plus. Yes. And here we need another resistor that is gonna have a value of 17. Okay. Then I enter to A from the independent voltage source. I get another wire here, 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 and this one we connect our node that we made last time. Then we finish, then we use with our V of our voltage, independent voltage source, this way, upwards, and we connect the other node that we made at the beginning. Okay, so now we go from the current source, the independent current source, downwards. We go this way. We need another battery here, another resistor, sorry. Another wire. And we connect here. Right here. Yes. And this one's gonna have a value of 21. Okay. Now here we also go downwards. We add another resistor that's gonna have a value of 53. We continue with another wire. And this wire is gonna go until V minus from the independent voltage current source. Okay, now we go to the A of the independent current source. Go upwards. This one, we need to go to here. And here we have a node also. So this node we need to connect it through to here. And then this one goes to here. And here I forgot a resistor. Yeah, there it is. And to the A minus is gonna be connected to this node. I get the wire, go this way, and go this way. There it is.
You're missing. You have two resistors with 1K value.
Sorry. Thank you for reminding me. Yeah, this resistor needs to go with a 20 value. Apply. And this one need to go with a 53 value. And now we're finished.
Okay, so now in order to interpret our results, we're gonna first go to the resistance of 20 ohms, which is the IY as shown in the circuit, and we can corroborate the results and we can observe that it's correct because in our calculations made by hand, we obtained a value of 0.714 amperes, which is what is shown in the bottom right of the screen. And for the BX, which is the value of the resistance of 15 ohms, we can observe that we got a voltage of 19.29, which is same as the value that we obtained in our calculations made by hand. So with this, we can conclude that our calculations made by hand were correct and that our circuit made on the software is functioning correctly.
Up next, we will put a photo of our procedure.
And now we're going to continue to solve the following problem, for which we used the nodes method. Now Leo will solve the second circuit on the software, for which we used the node and supernode method by hand, and we will use Leo's circuit in the software to corroborate our answer. Leo's circuit has two voltage sources, one independent voltage source and one current source, and several different resistors.
Yeah, so I'm gonna start with the lower meshes because they are simpler, and I'm gonna work my way up. So we start with a wire right here. We have a battery, which the positive is on the left side. We have a wire again going here, now here. Now we have a resistance of 8 kilo ohms. And continue this way right here. We have nothing here. We have this here. This. We have here a current source from the current, which goes from bottom to top. And this is 1 milliampere. So now we go to this wire right here. Oh, sorry. I don't know what's doing that. This wire right here. We have a resistor right here, which is 6 kilo ohms. And now we have a wire right here, and I will skip this wire because this in the problem this is our IX, which is goes from up to down. So I'm gonna skip this one. And now we can continue with this one, which is the central node with a wire, now with a resistor, which is 3 kilo ohms. We continue with a wire. We continue with our way up right here with another resistor, which is 2 kilo ohms. Another wire right here, right one here, which we have another battery with a voltage source with our positive side on the left side. So it goes like that. We got a right here, this right here, this right here. Let me change the voltage for voltages. This is 8. Change this one. Yeah, okay. And lastly, we have this one here, resistance, which is 2 kilo ohms. And we can use this part. And we have this one, the active construction break blocks, whatever it's called. And we have a current dependent voltage source, which is this one, fuente de tensión controlada por corriente. And in the problem, it's here in the middle. So I'm gonna move it right here. I think that's in the middle. And right, so we have a current flowing through the 6 kilo ohms resistor that which it will be defined from left to right to the CVS. From here goes up here, and the positive terminal on the right side, it's the output, right? So our voltage is given by 4Ix, which goes here, right here in the problem. So this is where I change this here, which is 4 times Ix. This is Ix. So we apply it, okay. And as I was saying, this part, this line, this wire, I'm sorry, this is the one that I was skipping. We will not put this one there because this goes through the negative side with the negative side, this negative side with this negative side. This positive side goes through this, to the upper node, and this one right here. So basically this is it. Now we only have to check for our current, which is putting the mouse over our CCVS. And as you can see right here down below at the bottom right, it says that our I equals 8.215.
So,
and our A is 1.668. So yeah,
so we can conclude that our procedure was successful due to the reason that in our handmade procedures we obtained the same value for IX.